You are a future engineer. You are welcome here in the past engineering. This is your beautiful channel, and in the channel, we're gonna learn the different types of stuff and the crazy stuff regarding the engineering law. And this series, the engineering physics, chapter 1, chemistry, thermodynamics. Let's start. And I'm gonna read it out and highlight the important point and so the derivation. This is only for those student and who hates, who bother, who don't like to go university and who don't like to attend any lecture, who feel boring, who feel really hard to attend a lecture and really want to pass the engineering. That's so interesting. That guy must be like me. So I'm gonna help such type of student. If you wanna score A plus or any grade above than 9 point something, you probably cut the video and go for the other beautiful channel. Okay, this channel is not for you. Okay, hope you guys understand. Okay, and this temperature and volume is a variable. For a small change, we know that the entropy change ds equals to dq by dt, whereas the ds is the entropy change and dq be the change in quantity of the heat and the amount of heat supplied to the system, and the T be the temperature in the Kelvin. And from the first law of thermodynamics, we know that from thermodynamics it gives the dq equals to du plus pdv, and from the thermodynamics we know that dq equals to this one is important in the most simplest law thermodynamics. The total heat contained in the system is equals to heat supplied to the system. That means dq equals to du plus pdv. So that the from equation and substitute the value of the dq in the equation, this equation, so we get this equation. This is the final equation, that means ds equals to cvdt plus pdv. That means the d equals to internal energy equals to cvdt, where the cv the molar heat capacity is constant volume. And from the ideal gas equation, and from 1 mole of ideal gas equation, you know that the pv equals to nrt, pv equals to nrt, from the pv equals to nrt, pv equals to nrt. And if you put that from pv equal to nrt, we get that that p equals to rt by v. Let's substitute that in the equation number 8. If you substitute that value in the equation number 8, and we get the ds equals to cv by dt and the rt dv dt. rt dt cancel. Okay, this one is the important formula for you. And let's move to next slide. Okay, okay. An integration, let's integrate that above equation. If you integrate that above equation, you get that integration, and taking the some limit, integration taking the limit from the s1 to s2, integration 1 to 2, cv t1 t2 and the b1 b2, and we get that integration and s2 minus s1, s2 minus s1, s2 minus s1, integration dt by dt equals to log t, t2 by t1, and the r is constant, and the ln b2 by b1. That means the this b2, t2 and the s2 are the final condition, and the t1, b1 and the s1 are the initial condition. And we got the one of the important formula among these, that is the del s equals to del s, that means s2 minus s1 equals del s, that means change in entropy equals to cv ln t2 by t1 plus the r ln b2 by b1. This one is the important formula. And for, and we have done this for the 1 mole of a molecule. Then for, let's do it for the n mole of the molecule. Let's do it for the n mole of the ideal gas. In the equation 2, ideal n mole of the ideal gas, and the equation 2 can be written as del s. Equation 2 can be written as del s equals to, and put the n right over here, and the del s equals to, we get this equation del s equals to n cv t2 by t1 and the nrt ln p2 by b1 for the n mole of the gases. And the ln, that means that this log can be changed, and this log can be changed, and we can replace this log, natural log, into log base to the power 10. And if you replace the log n natural log to the log 10, and we have to multiply 2.03 and cv and the 2.03 NCB log V2 by V1, and this one is the, you can write this one is the formula. This is green one, this shaded green one is your final formula, and you don't need to worry about this how to do this stuff. And simply by putting the calculator you can obtain and you can get your value. That's the easiest thing. Okay, hope you got it. Okay, and this one is the variation and variation of entropy change, this one is the entropy change at temperature and pressure is a variable. That means in that above equation we have done that the pressure and the volume is a variable, but this one is temperature and pressure is a variable. Let's look at it. And from the ideal gas equation we know that, and this one is the everyone non formula, and we know that, and we have read this formula is a combined gas equation. That means P1 B1 equals to P2 B2. That means this formula is the combination of Boyle's law and Charles law in chemical thermodynamics. Okay, in thermodynamics, let's rearrange that formula and let's get the T2 by T1 equals to P2 B2 P1 by P2, and also write it in simple formula. That means that B2 by B1 is directly proportional to and T1 by T2. You can write this too. Okay, no problem. Okay, no problem. Okay, let's see. Substituting this value in the equation, and in equation 2, and in the equation 2, and we know that equation 2, and in that above equation, that is the final del S equals to CV ln, that means the B2 by B1 plus the R R log T2 by T1. That is the simple form B2 by B1. That is the simple formula T2 by T1, B2 by B1, T1 by T2. That we have done that. Okay, and B2 by B1, and if you put that value in here, and if you put this equation right over here, and you get this, substituting B2 by B1, and you get this. This one is the important formula regarding this. No, okay, you got this del S CV ln T2 by T1 plus R log T2 by T1 into P1 by P2, and again you can do simple calculation right over here, and then the log using the simple function of the log multiple can be extended or can be done separately. CV ln T2 by T1 plus R ln T1 by T2 by T1 plus R, and some summation can be written as a single formula. That means you know that this can be taken as common. Yeah, did you get it? ln T2 by T1 and the ln T2 by T1 common, and the CV plus R and CV plus R, and let's solve that. Okay, right over here, and if you know this, and this one is the this formula, and this one is the, and if you take the common right over here, and you get this CV plus R, and we know that one of the important formula, that means the Mayer's law, Cp minus Cv equals to R. This one is another important formula in the chemical thermodynamics, and Cv plus R equals to Cp. You can write this Cv and just substitute the Cv plus R equals to Cv in the equation, in this yellow shaded equation, and you get the final equation del equals to n Cp del S equals to Cp ln T2 by T1. That means the Cp ln T2 by T1 plus so R log P1 by P2. Look at this. That means the temperature and the pressure is a variable, and you get this. And the temperature and the pressure is a variable. You get this. And if you want to remember this formula right over here, and just memorize the formula, right here, and del S equals to, if the volume and if the volume and the pressure is a variable, then del S equals to Cv. Right over here is the Cv ln T2 by T1 plus the R ln and V2 by V1. But if the temperature and pressure is a variable, del S equals Cp. Pressure is a variable, Cp ln T2 by T1 plus the R plus R ln P1 by P2. This one is the important formula right over here. You need to understand. This one is the important formula. Yeah? This one, this question number 13, this number 13 is the important one. This number 13 is the important one right over here, and this one is important right over here. Okay, and you can get it here, and this one is the important Cv, and this one is the important right over here, and we have read it, just let me do it. I have to get it. Del S equals to Cv ln T2 by T1 plus R ln V2 by V1, and here is the P Cv and for this the temperature and the pressure, that means the temperature and volume is a variable. And if you want to do this, and here is the another formula. What is that formula? For the pressure and the temperature variable, that means they look at this, Cp is only changed. First pressure variable Cp and T2 by T1 plus the R log P1 by P2. This one is the important formula right over here. Yeah? This one is the important one. Okay. Okay, if you don't know, if you want the more stuff like this, such type of stuff like this, and in engineering in the past one, I'll find this and subscribe the channel and seek for the next video. Okay, thank you. Hope you guys enjoyed the video. Thank you.